Hey guys, we are in our free online coaching classes for the NET examination, and this video will be the lecture 3 on this series. And the topic which I will try to cover is the chemical properties of seawater and the residence time, and the book which I referred is the Introduction to Chemistry of Sea by Michael Pilson and the Principles of Geochemistry by Mason and Moore. And this topic, which is in the fourth heading, that is in the ocean and atmosphere, which is in the part B. Let us get into the heading. The ocean covers an area of say 361 into 10 power 6 kilometers square, which is somewhat near 70.8 percentage of the Earth's surface. And the mean depth of the ocean is say 3800 meter, from which we can calculate the volume of water in the ocean, that is somewhat near 1370 into 10 power 6 kilometer cube. And at the surface, density of the seawater is at normal salinity and 0 degree Celsius is 1.028, and it increases with depth, and that is because due to the slightest compressibility of water under increasing pressure. The seawater that comprises about 91% of the water in the hydrosphere, and its composition can therefore be taken without any serious error as giving an average composition of the hydrosphere itself. Not only that, the circulation of water in the hydrosphere provides a mechanism for the geochemical changes through weathering, transportation of dissolved and solid materials. And you know that about 68% of the land area is drained to the Atlantic Ocean, but you can see that the constancy of the ocean composition indicates the well mixing of seawater. And this mixing erases all the variation in its chemical composition. The major dissolved constitution of the seawater is given in the table. You can see that the chlorine is in the highest percentage, that is 55.05, followed by Na, then SO4, then Mg, CaK, HCO3 and Br. So this is the overall concentration of the seawater by ions. And in the open ocean, the salinity of the average about 35 parts per thousand, that is grams per kg, which is in the range of between 32 to 37, and it is maximum I would say 41 ppt in the Red Sea and the Persian Gulf, which is because due to the evaporation is high in the Persian Gulf as well as in the Red Sea, and it will be low where the river as well as the melting ice enters the ocean. Although the total mass of the terrestrial water is insignificant in compared with the total mass of hydrosphere, we are interested in the terrestrial water also because these water are important in geochemically. It dissolves and brings the solid substance from the land surface, and the amount of dissolved substance will change from time to time as well as from place to place. The average composition of the river water is given in the table, which is in the next slide, which I will try to explain in the next slide. And it can be estimated that the total rainfall on the land surface is say 123 into 10 power 18 grams, of which 27.4 into 10 power 18 grams is drained on the surface to the oceans and sea. And the clerk estimated that the water carries almost 27.35 into 10 power 14 grams of dissolved substance with it. And this is the major dissolved constitutions of the river water, from which you can see the HCO3 is the highest in percentage, which is somewhat near 48.6, followed by Ca, then SO4, then Cl plus Na, then Mg. While comparing these two, that is the river water dissolved substance and the oceanic water dissolved substance, it is very clear that these two are totally different. That is, in oceanic water, you can see the sodium is in higher concentration, followed by Mg, then Ca. As well, if you see the negative ion, Cl is in higher concentration, followed by SO4 and HCO3. Whereas in fresh water, that is in river water, if you see the composition, the Ca is in highest concentration, followed by Na and Mg. As well, in negative ions, you can see the HCO3 is in highest concentration, followed by SO4 and Cl. So from this comparison, you can understand one thing, that the factors other than the supply of dissolved material in runoff from the land that regulates the composition of the seawater, and that thing is the residence time. Actually, in general, believe that the ocean is of a larger degree as steady state, that is the composition of the ocean is fixed, and the degree to which the concentration of any substance in the seawater is totally controlled by the residence time of the substance itself. Actually, the residence time of any element in the ocean is the average time that the elements spend in the ocean. that can be simply expressed in the form as residence time is equal to mass that is present in the ocean itself by the input rate. So if the difference between the mass percent by the input rate, then that indicates that the residence time of such element. And this is the list of few elements and its residence time. You can see that the chlorine's residence time is higher, which is 110 to the 6, followed by Na, then Mg, then SO4, then K, then followed by Ca. From this you can find out one thing, that the dissolved constitution of river, you can see the calcium comparing the CaCl and Na, that is calcium, chlorine and sodium. You can find that the calcium is in higher concentration in the river, followed by chlorine, then by sodium. But when you compare this thing, the same three in the oceanic water or in the sea water, you can see the chlorine is in the highest concentration, where in the river it is 6.5, but in the ocean it is 55.05. In terms of sodium, in the river water it is just 5.3, but in terms of oceanic water it is say 30.61. But when you are seeing the calcium that is in the river water, say it is 12.5, which is highest when compared to the other two, but it is the lowest in terms of oceanic water, that is just 1.16 percentage. So what controls this? That is the residence time. You can see that the calcium, the river water concentration is just 6.5, but due to its highest residence time, that is 100 into 10 to the 6, so it is in the maximum amount in the oceanic water. Is that clear? Where in terms of calcium, if you see, its percentage is 12.5, which is highest in this three, but its residence time is just 0.7. So the concentration of calcium in the ocean is very less, that is 1.16. Is that clear? So from these comparisons, it is clear that the concentration of element in the ocean is dependent on two factors. The first one is its supply from the surface water, that is from the river, and the second one is its residence time itself. So by understanding the residence time and the supply, you can say the ocean water composition, right? I hope I have explained the relation between the residence time and the composition of the ocean water as well as the composition of running water. If you still have any doubt, you can just mention it in the comment section, that I will clear in the later videos, right? As mentioned earlier, I have created the WhatsApp group. If you want to join this WhatsApp group, you can join it through the link that is given in the description, and that link will be available for a day. And if you miss the link, there is no any issue, you can just join it by sending your details to me through mail, right? And I have grouped my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram, and these are the links. You can also support us by like, share and subscribe. Thanks for watching. Have a great day.